Okay, good afternoon. It's F1 here. Okay, so we're going to continue our lessons of the integrations of rational functions. Okay, and today we're going to look at the rational function, which its denominator can be factorized. Okay, which the q, which is the denominator, can be factorized. Okay. So for instance, we have the example 9. Okay, let's look at the example 9a here. So 9a, so we have 2x plus 3, and x squared plus 3x minus 4. Alright, okay. So in here, okay, obviously this one you can factorize, okay, for the denominator, you can factorize it as x minus 1, and it can be x plus 4 here. Okay, so it can be factorized as x minus 1 and x plus 4 for the denominator. Okay, when you come across a rational function which the denominator can be factorized, okay, there are things that you have to do. Okay, you have to have the knowledge on how to decompose of these type of rational functions. Okay, so if you do not have the idea on how to decompose this rational function, please refer to my previous video regarding this. Okay, I will directly go to the decomposition. Okay, the general idea on how to decompose it is in my previous video. Okay, so let me write out this one. So we have 2x plus 3, and we have x minus 1, and we have x plus 4. Alright. Alright, okay, so same thing. What you have to do is you have to decompose it. So we have two factors here. So each of them will become the denominator. Okay, so then this is coming from here, this is coming from here. Okay, so we will have two fractions and join them with a plus. Okay, because on the top we have on the bottom we have the linear equations. Okay, so on the top we should have the constant. So the constant will be your a. Alright. Okay, this one is linear, and on the top will be constant. Okay, so because this is linear, then we will have constant. Okay, so that is what we learned from the previous video. We have the general idea on how to decompose it, but we have not learned how to solve this. Okay, let's solve it. Okay, let's solve this. How to solve this? Okay, so try to think of, okay, you have the denominator, that is x minus 1, x plus 4. Okay, try to factor this, okay, these two factors to each of the item that you see here. So if you factor, okay, this thing with x minus 1, x plus 4, you multiply with this item, okay, each of the item you multiply with this, whatever that I highlight. So if I multiply with x minus 1, x plus 4 here, I will remain of 2x plus 3. I multiply with whatever green color that you see, okay? So we will multiply each item that you see here, with x minus 1, x plus 4. Okay? Okay, so when this item you multiply with this, so of course these two you can cancel. Okay, and then okay, we only have whatever at the top. Okay, so this item, same thing, you're going to multiply with this. Okay, so you multiply this fraction with this. Okay, so what happened? So you will see that basically multiply, right? Okay, so this and this will cancel. It will cancel, and you're remaining of a and x plus 4 to multiply here. Alright. Okay, and then try to multiply this one with this. Okay, so if you multiply this fraction with this, you have to cancel the x plus 4, the remaining of bx minus 4. Okay, what happened after we have multiplied each of the item that you see in here, okay, with these x minus 4 and x plus 4, and you can see that the first line that are all in fractions, okay, it has changed to linear. It has changed to linear polynomial. Okay, so and in this linear polynomial, the next thing we're going to do is we're going to compare the equation that you have in the left and the equation that you have in the right. Okay, so we try to do the comparison. Okay, of the equation in the left hand side and the equations in the right hand side. Okay, so we try to compare the coefficient. When we're talking about coefficients, what you see here is coefficient of x. Okay, so we start from the coefficient of x first. Okay, so if we're talking about x, for the left hand side, we see that again the coefficients of x is actually 2 for the left hand side. So what happened to the right hand side? Okay, so we go for all those x. This x, this x. But this is actually, you can get the coefficient from expanding. Okay, so you expand this, you will have ax. Okay, so the coefficient of this is a. Ignore this because this does not have the x. Okay, so we continue the next. Okay, we go for the next x. We have here, this is bx. So the coefficients of this x is just b plus b. Okay, so compare the left, the x, the number that you see in front of the x is this left hand side. So the right hand side, that is coming from the right hand side, so we just focus on the x. Okay, so in here we see a, okay, and the next will be plus b. So that is for the x. So in here we form the first equation. Okay, the second equation that is coming from comparing the constant from the left and the right. Okay, so from the left, the constant that you see is actually 3. Okay, how about the right hand side? The right hand side, what you have here is you have 4ax. We have 4a. You have 4a. That is 4a. Okay, and then we have another one. This is also constant. This is minus b. Okay, the left hand side we have constant. That is 3. And right hand side we have 4a, and we have minus b. So now we have the second equations. So once we have the second equation, the next thing that we have to do is we have to solve it. Okay, so try to solve these second equations. Try to the left a bit. Okay, so for here, okay, so if we want to solve it, okay, we can cancel the b by using the operation of plus. Okay, you just plus down. So you plus down. So this one is give you 5. You plus down. This is 5a. You plus down. This is finished. It is plus b. Plus minus b is 0. So we got the a as 1. Okay. And then sub the a back into either one of the equations. So in here we will have this one is 2. Is a is 1. Okay. So we will obtain the b as 1. Okay, so once you have identified what is the value of a and b, the next thing is sub it back to the initial decomposition. Okay, so in here, okay, so we'll write it here. I'll just write it out. Okay, so we have So we will have that, okay, 2x plus 3 okay, this a is 1, so it's equal to 1 over x minus 1 plus the b is 1. Alright, okay, so we obtain that. Okay, that is for the decomposition part. Okay, but why we want to do the decomposition? Okay, so let's just see. Okay, now we're going to take the answer that you did just now. Okay, take this one. Okay, this one we have done with the decomposition. So this is the last step. So we have two different fractions. So this one become 1 over x minus 1. Just sub it with the last line that you have. Okay, so we have this. Okay, so you can see that basically we have a very difficult rational function just now. Okay, and by using the technique of decompositions, it become a much more simpler rational functions. You have two different fractions here, but it is very simple. It is very simple to integrate. Okay, so if you integrate this is actually equal to ln x minus 1. Okay, and this is actually equal to ln x plus 4 plus c. Alright, so this is the final answer of the integration.